Hi everyone, and welcome to another video. In this video I'm going to show you how to write a decimal number in BCD. So we have decimal to BCD, and BCD stands for binary coded decimal. So binary coded decimal. And so what BCD does, since base 10 that we are using for decimal numbers for everyday use, 10 is not a power of 2. So it's going to be a little bit complicated to change it to the binary code. So what they decided to do is to have exactly like hexadecimal numbers. They give 4 binary digits for each one decimal number. So if this is decimal, if this is a decimal number, this is the binary digits for that decimal number. This is just to make everything easier, and it's not as much used as they're not using BCD as much as they were using it before, but still in some environments they use BCD as well, so it's a good thing to know about it. So as we remember, one of the most common things that we were doing was binary. When we wanted to convert, actually let's write it in another color. So as you remember, we used binary to hex numbers. We represent binary to hex with this way of representing. So it means each digits in hexadecimal would be 4 digits in binary. And the reason for that is we had 2 to the power of 4, which is equal to 16, and hex is actually base 16, so this makes perfect sense to use 4 digits binary for hexadecimal number. And for that reason we can add, subtract, multiply, or divide with hexadecimal numbers which are converted to the binary. But since 2 to the power of 4 is 16 and 16 is not equal to 10, so when you're converting a number to BCD, you can't actually add and subtract with that number, because the biggest number, the largest number that you can go for BCD is 1001, which represent decimal number of 9 or hexadecimal number of 9, and anything over that will represent 2 numbers. So if you, for example, want to show 10, which is this binary number, this will represent 10, and 10 is not 1 digit anymore, it is 2 digits. So because of this reason we cannot add and subtract in BCD. But it is good to know how to transfer from decimal to BCD for a few purposes. It depends on what you're studying. It's going to be useful for you. So I'm just going to open another page, and we're going to talk about that. Okay, so we're going to convert decimal to binary, and then to BCD, and then after that we will convert the other way as well. For example, if I have a decimal number of 149 in decimal, and I want to convert that in BCD, as we said, for each digit we have to have 4 digits in binary. So if I want to convert this in binary, I have to have 4 digits for 9, 4 digits for 4, and then 4 digits for 1. So now how it works is this. First I'm going to find binary number for number 9, and this is going to be 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, again 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3. So these numbers represent, this one represents 1, 2, 4, 8, 1, 2, 4, 8, 1, 2, 4, 8. So now we have to add these numbers together to get number 9. So now I can just put 1 here and then 0, 0, and 1 here. So you will start with the biggest one in order to get the binary number usually. So this is 1001 and it represents 9. And then we want number 4, the biggest one is this one, so the rest of it have to be 0 in order for us to get number 4. And for this number, for number 1, we just have to have number 1 and the rest of it are going to be 0. So now the way we're representing this is 0, 0, 0, 1, and then 0, 1, 0, 0, and 1, 0, 0, 1. So this is the BCD number for our decimal number 149. And then if you want to go in reverse from BCD to decimal, we're doing exactly the same thing. So I'm just going to open a new page. Okay, in order to do BCD, to decimal, if I have a number 1, I don't really care how many I put, and I will show you why. Okay, this is my BCD number and I want to convert this to decimal. I'm just going to change color. Okay, in order to convert this to decimal, we have to start from the right side and we have to divide them every 4 digits, because we said every 4 digits of BCD represent 1 digit of decimal. So I'm going to count 1, 2, 3, 4, and then 1, 2, 3, 4. This is not a good number. I'm just going to make this 0 because that's more than 9, so we cannot use that. So 1, 2, 3, 4. Another one which is not good, so I'm going to make this one 0 this time, because the reason I'm changing this is 1011 will represent 10, and we cannot go any number higher than 9 because then it's going to represent 2 digits. So that is the BCD kind of problem, because you cannot represent all the numbers in binary into the decimal, so you have to be careful what type of binary numbers you're choosing to convert to decimal. That is actually not represented by any numbers, any 1-digit number of decimal, so we cannot use that. I hope I didn't confuse you, but that's how it works. You have to make sure that these 4 digits that you choose, if you count them, it's going to be less than 9. So that is another one. And as you can see, I choose another 4, but for the last one I left with just 2 digits, which doesn't matter. I can just add leading 0 to it, which doesn't add any value to this number, but it just makes it more BCD like. So what I'm going to do here, I'm going to put each number separately now. So this is my first digit, and then this is my second digit, this is my third digit, and this is my fourth digit. Okay, so this number represents 1 because this is 2 to the power of 0 and it represents 1, and the rest of it is 0. So that means our first digit is 1. So our first digit is 1. This is 2 to the power of 0 and it represents 1. Okay, and then this is 2 to the power of 0, this is 2 to the power of 1. The rest of them are 0, so they don't matter. So this is 1 and this is 2. If we add these two together, it will give us a 3. So that's 3. And then after that, we have this number. This is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3. This one represents 1. This one represents 8 because 2 to the power of 3 is 8. So what happens here is we're adding 8 and 1 together and it will give us a 9. And then I have another 9 here. Since it is the same thing as here, I'm not going to calculate it again. It's going to be a 9 here. So that means this BCD that we choose here, it's going to represent this decimal number, which is 1399 or 1399. So this BCD represents 1399. Thank you very much for watching and see you in next video. Bye.